Hey guys, so it's been 2 weeks. Hope things have been going pretty well. I know some of you guys are finishing your project one as of 7th of December. But yeah, if you have any questions, feel free to drop it in the chat or to the mentors you have. So, what I'm about to go through for this session is I want to make sure you understand what Spring Boot is about and how to set it up from the scratch. It might be, yeah, it's pretty simple if you know it, but you might also get lost in the middle if you've never touched it in the past. So Spring Boot is basically like Express. Like if you remember from I think part two, you'd have seen where you could declare things like your controller handler or request handler for HTTP request. That exact thing is what you can do with Spring Boot. But there are a bunch of other things that are very special about Spring Boot, one of which is that you can manage beans, which are basically singletons that you create out of your components. So where do you start? So essentially what we want to do is we have our MongoDB, our Spring, and we want to make a MongoDB, and we want to try also sending a request from here. And let's say we want to define a route like a, let's see. So let's do get slash, actually let's do a post first. So try to post a data that has a schema of ID, which is a string, and a email. Actually, let's make the ID the email and name. Name is also string. Cool. And then let's also do a get definition as well. So returns all users. It's pretty simple, just to drive the point that this is not different from Express or any other kind of backend framework you would have seen. So the first thing you do is you go into a place called Spring Boot Starter. Let's see. Yeah, so start.spring.io is where you begin. We're gonna use Gradle and Groupie. And for the language, we're gonna use Java. And Spring Boot, let's use 3.4.0. And for project metadata, doesn't really matter to be honest. If you want to keep it like this, or keep it like that. For nzpmc as com.nzpmc, doesn't really matter to be honest. And then we also need a Spring Data. No, Spring Data MongoDB. This allows us to very easily interact with MongoDB. And I think otherwise Spring Web. So this allows us to also create like controllers and a bunch of other things. So once we have these two dependencies, let's go ahead and generate it. So we take the zip off and let's try open this zip. So I downloaded this under downloads. This is lagging. And if I just open it, trust the project, and this should be this window. Oh, and just in case you guys haven't had experience with IntelliJ before, either because you used, I don't know, Eclipse or whatnot, Ultimate, that's the one that's given by your student license as well. So just probably just search up like IntelliJ license, IntelliJ with Ultimate, and then there will be some ways to get it. Anyways, so under the demo, you'll first be created with this demo application. Doesn't really have any meanings. So now that's your application, and if you want to give it a start, you you wait for it because it's still building the Gradle project. As we wait for this to finish, unless it already finished, I think it did. Yeah, so a lot of files you might not have any idea about, that's fine. Like build.gradle, don't worry about that for now. Gradle.w, Gradle.w.bat, yeah, none of that you have to care about too much at this point. Especially because you're gonna have to go into an existing repository later anyways. So if you see the demo here, you see that there's this demo application. So now if you press this run application.main, you will be able to run it. Cool. So now this is running, and you also see that there's this weird thing going on, and this is something that you can disable by, it's a pretty common problem. So what you do is you go into configuration for this run, so edit configuration, and under here you basically just put a VM options. So add VM options, I think this was VM options, right? Yeah. Then you press OK, and then you run it again. You'll no longer see anything. Cool. So now that's all done, let's now try creating a student. So actually, let's firstly try building a controller. So let's create a package called controllers, and the name doesn't really matter for the package, but here we make a student controller, and then you put a REST controller, and there are some other things you have to put. Let me just check. Yeah, so for you to actually communicate with the backend, you also need a REST controller here. So if you have this here, and let's say this is a user controller, sorry, let's say student. Now here you can actually create a bunch of methods, and each method is registered as your HTTP controller. So let's say post mapping and public response entity get, actually create student. And let's say, yeah, let's give it a type, and for the request body, let's say it's some map of string to string, and this is a increase the font size. I can't really increase the font size, but I can still zoom it in. So okay, so here, before we do anything anyways, let's just try to see how we can invoke this endpoint. So system.out, and this and create student endpoint was triggered. And then let's do a entity.ok and build. Now, if we try to run a postman against this, actually let me just rerun this application. And if I do a postman, cool. So yeah, one thing I didn't say is that this application is currently running on port 8080, which means that if I want to invoke any endpoint on this application, you have to do a localhost 8080 and student. Cool. So when I press send, it went with resolved whatever, and it said the required request body is missing because it actually wanted you to give it a response body. So let's actually give it some map. So if I go to here and do row text JSON. I can do gmail.com and name. Let's just call it email. And send it again. It will say query student endpoint was triggered. Then that's expected, right? Because we only wanted to print out the statement in the console. So this is the console that you see. And response entity.ok.build essentially just returns an empty OK response. So you see the OK here. What if you actually wanted to, for example, like store data to some kind of database, but let's say in-memory database. So what I mean by that is, instead of storing into the database, let's try to just create like a collection, a in-memory list, and then let's see if it, saves that. So I'm just gonna quickly create a model class. Student, and then string ID and string email. And name. And then you do a constructor of that. And so do and instead of actually having to do a student data.get and email manually like that, you can actually get the Spring to deserialize JSON into an object of your specification. So if I do, for example, like student, you'd actually be able to see student data dot, let's actually give it a toString here. So toString student data, and if I give it a run again, so unlike Express where whenever you change something, it reflected that in the runtime, you have to actually refresh this. So if you stop and rerun, and now you press send, you can see that the student data that was passed in was nzpmc@gmail.com for email and Hajin Kim for name. And that's exactly printing out as per the toString method. Cool. Now that means we actually got that data into a Java word, and when we have this data stored in Java objects, we can actually store that inside of our list, right? So if I do list of student and student database, let's just call it DB, because why not? So let's create a fake database, and here we can do db dot add and student data. And once that's done, you can actually get this stuff from get students endpoint. So if I do autocomplete, doesn't actually work properly, so you have to give it an actual import. I think get mapping is somehow very flaky. I don't know why though. So if you come across this problem, just type that in. You only have to do it once. So if you do return response entity dot OK and actually give it a data to show, and because it's not an empty body, so you can just ignore the build because the return type is response entity, unlike this OK, which returns a body builder. Cool. So if I stop and rerun, and if I post it, and then if I also do, k night, and I do it again, and then I somehow do like get on this, you get internal server error, and you wonder why, right? So no serializer found for models and had no properties discovered to create bean serializer. So yeah. So the reason this didn't work is because these email and name weren't actually accessible, and by that token really, like, this was complaining about it. Let's try it again. Cool. So you return the list, and if you try to post something to it, and then you press a get, then you get a list of students. That's exactly what we want. And we can also further go ahead and, I don't know, Hosea, Nate, okay, and then you do a get, then you do a send. We have both of them. So we got this basic, like, database-like functionality, and this is what you'd have already implemented as part of your project 1. Now imagine that you now wanted to use a database as a backing store. I'll link a bunch of resources to actually set up the local DB and like how to start it in localhost and connect to it. But for now, let's assume that we've set up the locally running database and basically like class in Java. So the way to define a schema is by giving it a document annotation, and you'll see that it's imported from org.spring framework, data MongoDB core mapping, and let's give it a name called student. And this means that when you persist any kind of data that is of a type student, it creates that object under a student table. And I'll show you what that means in the actual repository in Compass later to make it actually make sense. So now we have student here, and we want to create something called repository. This might sound confusing at the start, but it will make a lot of sense when you see it. Student repository interface. So now we increase the size of this a little bit and extends MongoDB. I think it was Mongo something. Yeah, it was Mongo repository announcement and string. Yeah. Repository and and when you have a red thing that's coming up, you just do a Alt Enter or Option Enter on Mac. So now you give it student and string, and you also give it a repository. So now we have this. The way you use this is actually pretty simple. So don't worry if a lot of this don't make sense in the surface. But what the student repository allows you to do that extends this is that it allows you to bypass the need to create any boilerplate code. I try to just instantiate this student repository, and I do student repository dot and find all. This actually returns all students from the database. Well, that's pretty amazing because I'm not sure how easy it is to do it in Express, but this is a single line. You don't even have to actually write a lot of code, and it will, well, you didn't really define this method, yet you're able to call that on the student repository. Same with create student. Like if I do student repository, let me just get rid of this DB. If I do student repository save student data, then really this already has done what it was previously doing. So with so little code, we were able to implement something like this, post mapping and get mapping. Now, one thing that you have to put is a auto-wired annotation. And this is something that you have to learn about in different sessions, but this is one of the Spring magic. It instantiates an instance of a student repository, or finds an instance that's available for the student repository and injects it inside of this controller. So now, even without doing something like a new whatever, it's able to find the instance of student repository. So that's the concept of singleton being created and that being injected into this field. But for our intent and purpose, we just need to have this in order to interact with student repository. So now if we just run it again, post, and we send it, and we try to get it, you can see that it created a document with Jose@gmail and 8K. Cool. So now we have that, and we actually want to observe that in our code base. Sorry, not code base, in our MongoDB compass. So the way we do that is you can connect your localhost by, I think if you do there'll be like a screen. Okay, this one I think. Yeah. Here you just put a MongoDB // localhost 27017. And then let's give it a name. And let's give it a color, yellow. Cool. So we have this localhost. Here we're not creating a database, we're connecting to the existing running database. Again, I'll link you how to set up a database on your local machine. So essentially a localhost is running, our local database is running on localhost 27017. So one thing I forgot to say is that you should create this file called application.properties under resources. So under resources, you already have this. So under here, you wanna give it some properties. So here we need these three things, and the server port, let's leave it as 8080, and this is gonna be just gonna be whatever you use for this localhost. So if I go to this one, so basically by default you're using this localhost 27017. So if you follow the instruction to run a local DB, that's the port that you have the database running at. And let's call this like demo localhost, just to be sure that, you know, like this name gets reflected on the database. So if I do that, and then let's try to run it on, Postman. So here you just do a post and send it. So now it's going, if you look at this demo localhost, so this is the name I gave, but I'm connecting to 27017 like you've seen before. And if I give it a refresh, databases, you'll see this demo localhost. And on the student, you see this object being created. Now, one thing you might find really weird is that like there's an ID and there's class. So first of all, this ID is there because we haven't actually given it an ID field. So it will automatically try to generate an identifier so that there's no collision between different objects, and it makes the query faster. But if you want to enforce that, you know, every student has different emails, for example, then you want to make that field on ID. So in that case, you actually want to use a annotation called ID. And if you do that, and if I run this again, did it run? Yeah, it did. Then go to MongoDB and I refresh it. You'll see that the ID field is actually now what takes our email. Well, that's really interesting. So before I had this, like if I kept posting a student to that post route, then it would have kept creating the same object with the same details every time I press it. So you might have like 10 documents that has the same email and the same name. But now because I have ID as host or email, now if I try to send it, doesn't matter how many times I do it, it will still be 2. Let's get rid of this first one for cross-compatibility reasons. Now, if we have this, if you look at this, what happens now is that, well, the field name has changed, right? So how would you be able to like retrieve a student and get the email? Well, so for example, like, what if you're storing this into a database and then you wanted to, for example, let's say you wanted to get the first student and get the email of them because they store that inside of the ID. Well, using this class field, MongoDB is actually able to figure out, okay, this student, you can use a blueprint of this class in order to deserialize it. So it will firstly find the student class and then see that there's, okay, so ID is email and name is just name. So we'll map this field to this field, and this will also map this name field to this field. So now you're actually able to retrieve that here. Cool. I think that pretty much shows everything. I think some details need to be talked about in terms of our, like the way Spring works, how the auto-wired thing works, and I guess in general, like how things are wired together. But this is essentially how you get started with Spring. And in your front end, all you really essentially need to do is you firstly create a backend with control like this, which basically maps to your, how should I say? Which basically maps to your, like, your previously existing APIs, and then you just connect it. But you want to make sure that the port that you use for proxy is not a localhost 3001. Because remember, if you look back at the Express, you had that running on the 3001, right? But if you now have the backend running at 8080, then you have to change that proxy URL to localhost 8080. Hope that made sense. I think, yeah, if you have any questions, then feel free to reach out. Thanks.